until all the lake's water dumped through a very deep slit, forming a canyon. The largest of these was the Grand Canyon. North and east of the Grand Canyon was a huge lake that I have identified and named Grand Lake. Its dumping released more water than is in all 5 of the Great Lakes combined. Grand Lake spilled over its rim, eroded its dam, 20 miles south of Page, Arizona, catastrophically forming the Grand Canyon within a few weeks.
Rapid deposition of flood deposits from tidal action means there was little time for erosion to occur between successive layers. On the long time scale envisioned by evolutionary theory, there should be considerable evidence found of erosion and infilling by successive geologic formations during the weathering expected over millions of years. The geological layers of the Grand Canyon are remarkable in showing little or no evidence of erosion between different layers. Instead, we see pancake layering, very much consistent with the rapid deposition envisioned by the flood model. Erosion did not occur until all of the layers had been deposited. But how rapidly could the canyon itself have eroded?
Freshly laid down sediments would still not have completely hardened into rock, which allows the possibility that erosion of the canyon could have taken place far more easily than if it had hardened into rock, as evolutionary theory has assumed.
However, under the right conditions, water can rapidly cut its way through the hardest of rocks, such as the granites at the bottom of the Grand Canyon. Those conditions involve cavitation.
Cavitation is the rock pulverizing process associated with water flows greater than 100 feet per second. As water detaches from irregularities in the bedrock channel, vacuum bubbles are produced, inflicting hammer-like blows on the bedrock surface, literally converting the rocks into powder.
A modern example of rapid erosion of bedrock from cavitation comes from Glen Canyon Dam on the Colorado River just above the Grand Canyon. Excessive snowfall from the high country of the upper Colorado River Basin in late spring of 1983 caused excessive runoff that poured into Lake Powell at rates of up to 148,000 cubic feet per second. This rapid inflow threatened to overflow Glen Canyon Dam. To control the high flow rates, the power plant was run at full capacity, releasing 28,000 cubic feet per second through the turbines. Then the outlet tubes were opened to drain another 17,000 cubic feet per second. This was still not enough. The emergency situation required engineers to risk damage to the spillway tunnel. And on June 15, the 40-foot diameter left spillway tunnel was opened to drain an additional 13,000 cubic feet per second, which was then raised to 17,000 cubic feet per second. Then on June 28, the flow was increased to 32,000 cubic feet per second. At this point, the water exiting the tunnel became red, and noticeable ground vibrations, earthquakes, were felt by engineers. Large blocks of concrete and bedrock came hurling from the 40-foot diameter tunnel. After closing the spillway tunnel, the survey team discovered extensive cavitation damage. The 3-foot thick steel-reinforced concrete lining of the tunnel was penetrated by huge pits. At an elbow where the tunnel levels out, a hole 32 feet deep, 150 feet long, and 40 feet wide was cut through the lining into red sandstone bedrock. This hole required 63,000 cubic feet of concrete to fill. The repair process to the enormous hole shows the vast extent of the damage. The speed of erosion in the Glen Canyon Dam spillway tunnel occurred very rapidly during the period when the red color of water appeared and ground vibrations were generated. It is possible that cavitation was pulverizing concrete, steel, and sandstone at the rate of 1,000 cubic feet per second during the peak period of erosion. The destructive effects of cavitation at Glen Canyon Dam tell us the Grand Canyon could have been eroded very quickly by the sudden release of a huge volume of water above the canyon. But where did the water come from, and what caused its sudden release? Dr. Brown's studies on the Grand Canyon provide one of the best answers.
Most people are told that the mighty Colorado River carved the Grand Canyon over millions of years. But if people could study the canyon from an aircraft, they could see its vastness and how tiny that river is in relation to the canyon itself. There is no river on earth that could carve this big hole in the ground, even over billions of years. If the Colorado River carved the Grand Canyon, the first question we should ask is, where did all the eroded sediments go? There should be a very large river delta at the end of the Colorado River. It's not there. Furthermore, geologists can't find a huge river delta anywhere near this part of the world. So we need to ask ourselves, where did the dirt go? At several places on this platform that overlook the Grand Canyon, there are small mountains or buttes whose horizontal layers tell a fascinating story. The layers line up with each other, so obviously they were at one time connected. Something must have come along and removed a several thousand foot thick layer of softer material that was once where we now are. So we need to explain not only where the dirt from inside the vast 200-mile-long canyon went, but also where did the thousands of feet of dirt go that was once above where we are now and spread out for tens of thousands of square miles. This particular formation, called Red Butte, not only still has some of these horizontal layers, but there's another clue sitting on top. The topmost layer is a lava flow. Lava only flows downhill. Therefore, at one time, the land surrounding the top of this butte must have been even higher. So again, where did all that dirt go? Grand Lake spilled over and eroded its dam catastrophically, forming the Grand Canyon to the southwest within a few weeks. One other large post-flood lake that geologists recognized was once near here was Hopi Lake. As Grand Lake catastrophically dumped, I believe it eroded the western boundary of Hopi Lake, causing it to also spill out. Where did all the dirt go? It was spread out over southern Arizona and parts of California and Nevada rapidly.
The evidence supporting the biblical worldwide flood about 4,300 years ago is mounting. For the Grand Canyon, the flood explains how the sedimentary layers were rapidly deposited as the waters rose, and how they were quickly eroded as the waters subsided. We have also seen where the dirt went. And just as we have seen evidence of the rapid burial of pre-flood vegetation to produce today's coal and oil, we will now see fossil evidence of rapid burial of pre-flood life forms. Indeed, some of the most remarkable evidence of rapid deposition of flood sediments comes from well-preserved fossils found in certain parts of the earth.
Perhaps the best fossil evidence for the rapid burial of plant and marine life is found in southwestern Wyoming at Fossil Butte National Monument. During the past 100 years, scientists and private collectors have collected thousands of almost perfectly preserved fossils from sites within the monument, especially here at Fossil Butte itself. It's an amazingly diverse collection of fossil turtles, palm fronds, crocodiles, leaves, insects, branches with nuts still intact. There are even fossil stingrays, whose skeletons of cartilage are known to disintegrate rapidly, proving that burial of all these life forms was indeed quite rapid. But this isn't all. Perhaps the most spectacular evidence of rapid burial of all the fossils within the monument are the billions of the more than 20 kinds of fish. This slab of rock in the Monument Visitor Center, which measures about 9 feet by 5 feet, shows vividly just a few of that number. Amazingly, many of the fish retain not only their entire skeletons, but their teeth, delicate scales, and skin as well. The vast number of fossil fish at Fossil Butte has left evolutionary geologists with a vast unsolved mystery. In two sections entitled Ideal Conditions for Fossil Making and Unsolved Mysteries, the National Park Service's brochure on Fossil Butte